In this video, you will learn how to identify the critical parts and how to graph a horizontal parabola, and then be able to explain it to your partner. So today we're going to look at conic sections. A conic section is formed by the intersection of a plane and a cone. For a parabola, that's going to be taking a cone and slicing it perpendicular to the base, so vertically, and that gives us our parabola shape. So let's look at what a parabola is. A parabola is going to be the set of all points x, y that are equidistant from a fixed line, which we call the directrix, and a fixed point that we call the focus. The directrix is this dashed blue line that you see on the screen, and the focus is the orange point in the middle. Let's go ahead and label those. Now, like we said, every single point on this parabola is going to be the same distance away from both the directrix and the focus. So what that means is if I take some point on the parabola and I think about the shortest distance to the directrix, which is a perpendicular line, and then the shortest distance to the focus, these two lengths should be the same. Now, there's also a midpoint of the segment that goes from the focus to the directrix. This midpoint is called our vertex. There's also a line passing through both the focus and the vertex. That's called our axis of symmetry. Notice the axis of symmetry and the directrix are perpendicular. Lastly, we have these two red dots. What these red dots are the endpoints of the latus rectum, or the LR. They determine how wide or how skinny our parabola is going to be. Now, last year you talked about vertex in standard form, which is y equals ax squared plus bx plus c. This year we want to know a lot more critical information, so we need to look at a parabola in vertex form, which you can see on the next page. So when we have a parabola horizontal in vertex form, it's going to start off x equals. After that, you're going to see some value a times the quantity y minus k squared plus h. This is all the critical information that we need to find. The direction it opens, the vertex, axis of symmetry, a value for p, which tells us how far away the focus and the directrix are from the vertex. We also need to find that focus directrix, the length of the latus rectum, and its endpoints. We're going to do all of this while creating the graph at the same time. So let's start off at the top with how it opens. There's two things you want to look at. First of all, because it's x equals, that's why I know it's going to be horizontal, so either opening left or right. Then, if you have a positive a, it's going to open the positive horizontal direction, to the right. If you have a negative a, it's going to open the negative horizontal direction, which is left. Next, we want to look at our vertex, and that comes from the values h and k. Something to notice is that k is with the y value, and so that is going to be the y value of your vertex. H is out here on the outside with x, and so that will be the x value of your vertex. It's very important to know that because, as you see, it's flipped from the order they appear in the equation. Second thing you should notice is that because it's y minus k, I want to take the opposite value of what we see here. So if I had y minus 3, I would actually put a y value of positive 3, even though it was minus. Then, because we have plus h, we're going to actually add maybe 2. And so I would put a positive 2 here for my vertex. Next, we have the axis of symmetry. As we saw in our diagram, the axis of the symmetry is going to go horizontal when our parabola opens horizontal. All horizontal lines start out y equals. Therefore, since it has to go through the vertex, it should equal k, whatever the y value of your vertex was. Next, we need to find p. P again is going to tell us the distance from the vertex to both the focus and the directrix. And we get that by using the equation 1 divided by 4 times that coefficient of a. Next, we come to the focus. Again, the focus is going to be p units from the vertex. So since we're moving horizontally here, it's going to be the h value that is changing. So I basically take my vertex and just add p to h. Similar for the directrix, I need to have the equation of a line that is p units away from my vertex. Now, because the directrix has to be perpendicular to the axis of symmetry, the directrix is going to be vertical. All vertical lines are x equals. And because it's going to be the opposite direction, I'm going to have x equals h minus p. So I'll take my x value of my vertex and subtract p. Next, we come to the length of the LR. This is going to be 4 times the absolute value of p. Since this length is a distance, you need to make sure that it's always positive. And then we're going to find the endpoints of the LR by going to the focus and going half the distance up and down. Now that we have all of our definitions, let's try a couple of examples. In example 1, we need to do all of the chart of x equals 1/12 times y squared. And the first thing that we notice is this is not in our form that we just defined everything in. So let's go ahead and put it in that form. So we want to go ahead and do x equals our a value of 1/12 times the quantity y minus, and we'll go ahead and put a 0 here because I can always subtract 0 from something without changing its value, quantity squared, and then again we'll put another 0 because I can always add 0 to something without changing its value. From here, the first thing I need to figure out is what direction it opens. Because I have x equals, that tells me it's horizontal, and a positive a value of 1/12 tells me I want to go the positive horizontal direction, which is to the right. Next, I want to look at my vertex. My vertex, again, remember, is going to come from these two values here, the 0 and the 0. Now again, normally the x value of my vertex comes from the outside, what's added, and the y value comes from what's inside the parentheses with the y. Normally it's the opposite sign, but since 0 is neither positive nor negative, we're just going to have 0, 0. At this point, I would go ahead and plot your vertex on your graph. Next, we need the axis of symmetry. Since the axis of symmetry is going to be a horizontal line that cuts through my vertex, since the vertex is 0, 0, I need to draw a horizontal dashed line through 0, 0. All lines that are horizontal have the equation y equals, and then again it goes through the vertex at my y value of 0. Before I can figure out my focus and my directrix, I need to figure out the value of p. P again was 1 divided by 4 times a. And so if I do 1 divided by 4 times 1/12, I'll get my value of p. Now to calculate that, we're probably going to want to use our calculator. So I'm going to go ahead and enter 1 divided by, but I want to make sure I divide by the entire denominator, so I'm going to put a parenthesis. Then it's 4 times a fraction. I always put parentheses around my fraction. So 1/12. Because I have two open parentheses, I need to have two closed parentheses. Enter. It looks like our value of p is going to be 3. What this means is that our focus is going to be 3 units away. Now, since it's a positive 3, I should go 3 units from the vertex, the positive horizontal direction. That puts me at a point of 3, 0. At this point, notice all the y values of the first 3 critical information are the same of 0. You'll notice that every time you have a horizontal parabola. Next, I need to look at the directrix. The directrix, remember, again starts at the vertex but goes p units the opposite direction, so back 3. But this is not going to be a point. Our directrix is going to be a line perpendicular to the axis of symmetry. And so here, that has to be a vertical line. All vertical lines have the equations x equals, and then back 3 units would be at -3. Next, I need to find the length of my LR. To do that, remember I'm going to take 4 times the absolute value of p. And so here, that's going to be 4 times the absolute value of 3, which is 12. Now remember, that's 12 units from endpoint to endpoint. So when I'm at my focus, I actually only want to go 6 units up and 6 units down, for a total between my 2 red dots of 12. Once I have those marked, I can go ahead and name those ordered pairs. First one's at 3, +6, and the second one's at 3, -6. Lastly, I just need to draw my parabolic shape through the vertex and those endpoints of the LR. Once we've done that, we have our graph. Please now pause the video and complete number 2. When you're done, check it with the answer. Please now check your answers for number 2. You'll notice in number 2 that this parabola opens to the left because we had an x equals equation and a (-1/4) was negative. Then you'll notice that our vertex came from 0, 0 once we put it into the vertex form. Then the axis of symmetry had to cut through the vertex horizontally, and so that was the equation y = 0. Next, we needed to find the value of p, the distance from the vertex to the focus and the directrix. We got that by doing 1 divided by 4 times our a value. In our calculator, we would need to enter 1 divided by 4. In our calculator, we would need to enter 1 divided by parenthesis to get the entire denominator, 4 parenthesis, since this is a fraction we're now entering, our (-1/4), and since we had 2 open parentheses, we want 2 end parentheses. That gives us our (-1). Once we know it's (-1), that tells me to move (-1) to the focus to get a point of (-1, 0). For the directrix, I again start at the vertex and move 1 the opposite way, so +1. Then I have to remember that the directrix is a perpendicular line to the axis of symmetry, and so the equation for that line would be x equals, and then here a +1. Next, for the length of the LR, I want to do 4 times the absolute value of (-1. So 4 times +1 is 4. But remember, that's the distance between both endpoints. From the focus, I only want to go half that distance up and down. And so 2 units up puts me at (-1, 2, and 2 units down puts me at (-1, 2. The last step again is to draw your parabola through the vertex and those endpoints of the LR. At this point, Please talk with your neighbor and compare the similarities and differences between the horizontal and the vertical parabola. Then complete the next two examples on the next page. These are the same examples that your partner has already done. When you are finished, you may work on your homework, which is a worksheet.